Welcome back to Ladies of Another View on Back, and we are going to be joined by Dr. Wayne Barkhouse at UND. He is a professor of physics and astrophysics. Welcome to the show, Dr. Barkhouse.
Thank you very much.
Now, before we get started, can you explain what is astrophysics?
Sure, it's the application of physics to things beyond the Earth. So normally the study of the universe, stars, galaxies, those sort of things. So it's just the application of physics to, if you like, to the big picture view of our universe.
And I don't know anybody that doesn't find some level of interest in the planets and the stars because it's just such a mysterious and wonderful world. Let's talk about this lunar eclipse that's coming up this Wednesday.
Right, so this Wednesday on May the 26th, we have a lunar eclipse that for best viewing is towards the west. But for North Dakota, the further west you are, the more you'll be able to see of the eclipse before the moon sets. So the best time to go out is approximately 5 a.m. and then watch the moon all the way until it sets in the western horizon. So the clearer you have of a view towards the western horizon, the more you'll be able to see of the moon during the lunar eclipse itself.
What exactly would people be seeing, and what time does it happen?
Right, so 5 a.m. in the morning, Central Daylight Time is the best time to go out for our state. And what you see is that the moon actually goes into the shadow of the Earth. So it's that special arrangements where the alignment is just right, that the sun, the Earth, and the moon makes a perfect straight line. And the moon enters then the shadow of the Earth. And from that, we can see or get a lot of information. For example, it's interesting to note that ancient astronomers 2,000 years ago were able to determine that the Earth is spherical in shape. And they did that by noting that the shadow of the Earth on the moon is actually round in appearance. And that is what you would get if the Earth was spherical in shape and the moon enters then the shadow of the Earth. Today, of course, in more modern times, we study the light that's reflected from the moon during the lunar eclipse. And that tells us information about the constituents of our atmosphere, what's going on in our atmosphere in terms of how much dust there are. And so we know there are times when we have more volcanic eruption, there's more dust in the upper atmosphere, and that actually changes the amount of light that passes through the edge of our planet, through the atmosphere, and gets refracted off the moon's surface, and then gets reflected back to the Earth itself. So we can still get some useful information today.
You know, lunar eclipses, you don't need to have special glasses to watch, like the solar eclipses. You know, this last big solar eclipse, we ordered special glasses, 200 of them, so we could be real generous with our neighborhood. And they arrived 2 hours after the eclipse ended.
Oh,
so.
no.
No.
I know. So anyways, with the lunar eclipse, you can just go outside. You have to set your alarm, though, probably, to get up early. Dr. Barkhouse, I went to the link that you sent me about the lunar eclipse, and it said that in the past, this day was cloudy 70% of the time. Like, that's a lot. Do you have any idea what the long range, well, the forecast isn't that long range for Wednesday is?
No, I think it's relatively okay. I mean, it was better than having the eclipse a couple days ago. And so it's just one of those things, you take a chance of it. But the thing about a lunar eclipse is that it appears quite frequently compared to a total solar eclipse. And so as you mentioned, we had a total solar eclipse that was visible from the United States back in 2017, and we'll have another one coming up here in 2024. And those events are fairly rare if you stay sort of in one location on the Earth. A lot of people who study solar eclipses actually have to travel around the world, getting to places where the shadow, in this case of the moon, touches the surface of the Earth. So those are relatively rare. But our lunar eclipse, we have another partial one coming up in November. And actually, a year from now, we'll have another total lunar eclipse that's viewable from North Dakota.
Okay.
Dr. Barkhouse, when there's a full moon, they say that there are physical and psychological effects that happen to us humans on Earth. Anything like that with an eclipse? Is there anything blocked?
No, and then getting back to your point about a full moon, that's when people go crazy, quote unquote, right? If you want to say that. I've seen lots of studies that were done, and there is no evidence at all that suggests a correlation between the phase of the moon and the behavior of human beings. So if there is something there, it's more psychological than anything. It's not a true effect. But during eclipse, such as a solar eclipse, we do know that that affects animals. For example, when the sky darkens because the moon is blocking out the light from the sun, the animals are tricked into thinking that it's twilight, and they start doing the things they normally do. So the birds, for example, will start getting ready to roost and so on. And then, of course, a few minutes later, typically that's when the sun comes back out again. And they're like, wow, that was a quick night, that kind of thing. And so those kind of effects can happen. But in these sort of phenomena, we know exactly what they're all about, how they come about, the true nature of them. And so we basically just sit back and enjoy the event itself. But that wasn't the case hundreds and thousands of years ago. People didn't know what the eclipses were. And there are a lot of tie-ins. For example, if you see a solar eclipse, that may forecast doom that's coming to some country. And so there could be political upheavals because of the appearance of eclipse. But that's, if you like, that's the category of superstitions and not knowing what the true nature of these events are.
We actually saw the total eclipse near Yellowstone. I'm forgetting the name of the park we were at, the national park, but it did get completely dark, and we started hearing the crickets coming out, and it was like nighttime. And what's amazing is even when there was only 10% of the sun showing, it was still fairly light out. So it makes you realize how powerful the sun is. It looks like it was dusk. And you say they thought that maybe political upheavals happen. Well, just saying, it seems like we sure have. I'm not being superstitious, but I'm just saying the world has certainly gotten political.
Yes.
Well, let's move on to talk about the sun and sunspots. Can you explain what sunspots are, and have we had an increase of them?
Right, so sunspots are really magnetic storms on the surface of the sun. Their temperatures are less than the surrounding area of the sun that we call the photosphere. That's the part of the sun that you see when you look at the sun with your eyes and sort of just glance at it. And because it's cooler than the surrounding photosphere, that makes the sunspots appear dark when you look at them through, let's say, a special telescope. Of course, you never, ever want to look at the sun with any type of magnifying instrument like binoculars or a telescope of any type, because you will permanently damage your eyesight. So please don't ever do that. In order to look at the sun, to see sunspots, we put special filters on our telescopes. And these are, expensive filters. And we can look at the different sunspots and keep track of their number. In fact, this was first done by Galileo, who was the one to use the first telescope to look at the sky. The telescope was invented by another person, but Galileo published his results and first to do so. And he noticed that the sunspots, which travel across the surface of the sun, he could actually track how long it takes the sun to rotate once. And he came up with an answer of about 1 month, which is the correct value for the rotation of the sun. Over time, we notice that the sun goes through various activity. There are times when there are less number of sunspots visible and times when there's a lot. And right now, we're just getting out of what we call solar minimum. So this is a time when you have a minimum number of sunspots, and we're heading towards solar maximum, which should occur roughly in the year 2025. Altogether, it's an 11-year cycle. And that has an effect on the activity that we see emanating from the sun itself.
Okay, and then does that leads to the northern lights, right? Does that affect it? But I don't want to, you sent me some very dramatic photos of the northern lights, and we're going to look at those when we come right back after these messages with Ladies of Another View on Beck.
Jeez, what a mess. Look at that. There's roof stuff everywhere. It's so embarrassing. Ruins the neighborhood. Come on, humans. Let's get this fixed.
Don't let your roof go to the dogs. Call America's Best Contractors for your free estimate.
Need a new woof?
After checking with the rest, go with the best. America's Best Contractors. 258-2412. Online at americasbestcontractorsincorporated.com.
Your Bismarck Bucks are hitting the road this week, Saturday, May 29th, for a 7:05 p.m. kickoff in Des Moines, Iowa, as we take on the Iowa Barnstormers for the IFL Game of the Week. Catch the game locally on Beck Sports and on our national television partner, Stadium, as the Bismarck Bucks look to improve to 4-1 on the season. Hey, go Bucks!
Hello, I'm Mike Lindell, inventor of MyPillow. Thanks to your support, you've helped make MyPillow become one of the fastest growing companies in America. Over the last 12 years, you've helped My Pillow create thousands of jobs right here in the USA.
When I got My Pillow, I'm asleep almost immediately. I stay asleep at night and I wake up more well-rested in the morning.
That's why I invented My Pillow. My patented fill adjusts to your exact individual needs and helps keep your neck supported and aligned. I'm interrupting this commercial right now. Retailers have canceled My Pillow, and to thank you for your support, I'm gonna pass the savings directly on to you. For example, you get my 6-piece towel sets, regular $109.99, now only $44.98, or My Pillow dog beds for as low as $19.99 with your promo code.
For the best night's sleep in the whole wide world, visit mypillow.com.
Ever been in a cave before?
It's our first time.
All right.
Where are you going?
I'll see you at the car! How will we? The car! Your offer has been accepted. Ever bought a house before?
It's our first time.
All right.
Where are you going?
I'll see you at the closing. But how will we? The closing!
Hey everybody, I'm Doug Billings, your host of The Right Side with Doug Billings on Beck News. We bring you high-profile guests, ladies and gentlemen, exclusive guests. Now, you're not going to see these guests in most of the mainstream media outlets. Another thing that I do here is give guests a platform to speak freely. You're not going to see me censor anybody. Please join us, won't you? Weeknights right here on Beck TV and online at beck.news. Cheers.
Welcome back to Ladies of Another View on Beck, and we are joined once again with Dr. Wayne Barkhouse from UND. He's a professor there in astrophysics, and we've been talking about sunspots, and the more sunspots, the more northern lights, right? And he, go ahead.
So there's a correlation between the activity of the sun, and that's related to the number of sunspots and the occurrence or frequency of the northern lights. So in general, when there's more sunspots, the sun is more active, then we have more of these northern lights, and of course the southern lights as well, but for us it would be the northern lights that we would see. And that's related to the fact that during these activities, when the sun is more active, there are a lot of charged particles that emanate from the sun. So the sun in some sense bleeds. There are material masses of particles that emanate from the sun. And sometimes we have what's called these solar flares, or a fancy terminology we use is coronal mass ejections. And this is where essentially, if you want to think of it this way, the sun burps and you get a huge amount of material that's released suddenly from the sun itself. Now that material moves away from the sun. It's reached what we call escape velocity. So those particles will never return to the sun. If the Earth happens to be in the right position, and that's right if you want to see northern lights, then those particles will hit the upper atmosphere of the Earth. And what they do is they follow the magnetic field lines associated with our Earth, run into the particles that make up our atmosphere, the oxygen molecules and the atoms of nitrogen and so on. And those atoms and molecules get energized. And during the nighttime, you can see that energy being released by those atoms and molecules. And that's what we see as the northern lights.
Okay, so here are some, you sent me a few photos of northern lights where you see those lights, and we talked during the break. Andre, you had a question you were?
Yeah, so the camera really picks up the color quite nicely. You can see the green, but to the naked eye, it's not as easy to see. So how can you tell the difference? How do you know when you're really looking at the northern lights?
Right, so what you look for, first of all, it's best to get outside of the city or community that you live, that they have a lot of light. So you want to be out in a dark sky site. And what you'll notice is that at times you will be able to see the colors quite distinctly with your eye. Of course, as you mentioned, the camera picks it up much easier because you can do a longer exposure time and the camera is more sensitive. And so what you get to look at then is you can see the colors, but for northern lights, they change their patterns over seconds and minutes. You see a sort of shimmering effect, and they're dynamic, if you like, they're constantly changing. And that's something that you would never see on an ordinary night. So one particular night you happen to go up and see this effect, then you know it's probably related to the northern lights itself. It's quite distinguished. Now it's interesting to note that in the quote unquote old days, when people didn't know the nature of what the northern lights were, some people had suggested that what you're seeing is the sunlight reflecting off of the ice in the North Pole. And that's what gives rise to the northern lights. But of course, that's totally wrong, as we know nowadays. But it's just sort of the myths that get passed around for time as we try to explain everything that we see in the universe around us.
So you said that these solar flares are kind of have a magnetic property to them that help create the northern lights. So if there is an intense one that, excuse me, comes towards the Earth, it can mess up some electronics, that type of thing. Is it something that would actually like stop a car battery?
No, it wouldn't be that. If it was that powerful, we're in big trouble.
That's what I'm thinking.
So back in the middle of the 1800s, we had an event called the Carrington event, where we had a huge solar flare on the sun. And that caused a big outburst of these charged particles to interact with our upper atmosphere. And those charged particles actually was able to reach near the surface of the Earth. And they caused the telegraph system in different countries, including the United States, to short circuit at the time. So there were reported fires at different locations. Even operators got electrical shocks from the interaction of these charged particles with those telegraph lines. So in general, you need sort of long sort of wires in which electricity and current can peak or and sort of build up, if you like, over large distances. There were also events that happened in Quebec several years back where they had loss of power. There was short circuit that happened because of these solar activity that interacted with the power grid. So it's one of these things that it can happen in our sun in the future, and it most likely will, that we'll get a huge event like the one in the middle of the 1800s. And that will affect today, of course, our satellites that are in orbit. And we have to be wary of that because we rely so much now on satellites for vital communications that if those satellites get destroyed, it's going to take, a decade or more to reestablish that system. And that'll be a tremendous impact on our society. And one of the things we can look at is not just our sun, but we can study other stars that are just like our sun in terms of the type of star. And what we find is that a lot of those stars are very active. They have lots of solar flares that occur from time to time. And so that's really scary in a sense. And so it's one of those things that if you put a satellite in space, you want to make sure that you build redundancy in your system. Now, we do have satellites that are far from the Earth, of up to 1 million miles or so, that keep an eye on the sun, and they can give us sort of a head start to say, hey, there's an event coming, it'll reach the Earth in 1 hour, and then satellite operators can start shutting down their systems so they won't get overloaded. So there's some effects some activity we can do to try to mitigate the effect here on the Earth. But a real powerful solar flare will cause a major problem to our technology.
And what you're saying is it is possible that Carrington event, and anybody who wants to learn more about it, because I have read about it, you just look up the Carrington event where all the telegraph machines went down, and if there was something that hit us again to the same strength, you're saying that it would be pretty catastrophic, right? That there might be some security measures in place to shut down satellites, but for the most part, we're going to struggle here on Earth, right, if that happens again?
Definitely. I mean, if you rely on a society that you're into, which has nothing to do with technology, then you're fine. But for most people in the United States and many other countries around the world, we rely on technology for commerce and business and transaction. You think of money transfers, just those kind of things. I mean, it'd be no internet, there'd be lots of problems that way. Heaven forbid the TV would go down and so on, right? We wouldn't be able to see this beautiful show that we're on. And so that would cause a lot of major disruption, and it'll take several years to build that system back up again.
I was taking a look at one of the websites in prep for today's show, skyandtelescope.org. And the articles that were on there kind of fascinated me, but one kind of concerned me because they said with some of these solar flares that airline pilots and flight attendants are at risk for some health issues because of it. The pilots have a greater instance of cataracts, and the female flight attendants have miscarriages and some of those issues. But didn't say anything about the passengers. Is it safe to fly?
Okay, so the one thing you have to worry about is the magnetic field lines emanate from the poles of our planet. And so the charged particles that come from the sun, they follow those magnetic field lines. So that's why we have the northern lights and the North Pole and the southern lights and the South Pole. So those charged particles follow those magnetic field lines and crash on the polar regions of the Earth. Well, if you fly a lot of the polar flights, you go over the pole of the Earth, you're exposed to that radiation. So at times of a huge amount of solar activity, you can, acquire radiation exposure that's way above average that you normally would acquire. Now, passengers on the flights, they would only be on that flight maybe a trip a year or so that go through that region. But pilots and other people that work on the airplane, they may be making, a couple flights a day, and 5 days a week through that region. And so that can really build up your radiation exposure. So you really have to worry about those sort of things.
Wow, that is interesting. A job hazard for being a pilot and a flight attendant could be radiation from solar flares. I never
would
heard
not
of
have
that
guessed.
before.
I would not have guessed.
Interesting.
Yeah, isn't that amazing? Well, how about you tell us about what black holes are?
Yeah, so black holes are very interesting. In some sense, they're one of the hottest topics in theoretical research today. They are masses that have collapsed to the point where the gravity on its surface gets strong enough that even light can't escape. And you might wonder, well, how small do you need to make an object? If you took the Earth and you could magically compress it so it was no larger than a sugar cube, even traveling at the speed of light, you would not be able to escape that object. And so therefore, if light can't escape, nothing else can as well. And so the object would look dark, for example. That's what we call a black hole. Now, of course, we can't take the Earth and squeeze it down to the size of a sugar cube. We don't have that technology, whatever that technology would be. But nature naturally forms these objects, and most of them form at the end state of a massive star. When a massive star dies at the end of its life, it can collapse because of gravity and form one of these highly compressed objects and turn into a black hole itself. Now, what actually happens inside of a black hole, that's up for debate. There's a lot of opinions, there are a lot of suggestions, but we really need to increase our understanding of fundamental physics in order to understand what actually happens inside of these collapsed objects.
It is fascinating because you think, where's everything going?
Well, in Star Trek, all the ships kind of go into
Yes.
the black hole and they never come out.
Yeah, great
Gravity for you.
Great for space movies. What do you think, Dr. Barkhouse, about human beings going to Mars?
I mean, it's a natural thing. We're going to evolve just like people spread across the United States from east to west and settled the land. We're going to settle the solar system. And then in the future, far future, we're going to make our way out into the stars and settle, look at the stars, survey them, settle any planets that will be going around those stars and so on. That's just a general kind of thing. The only disappointing thing is the progress that happens during our lifetime, because it's extremely exciting. Who wanted this? Who wouldn't want to see a mission going to Titan, a planet that orbits, or a moon that orbits the planet Saturn, for example, and explore what's on its surface? But that's not going to happen in terms of human beings visiting that moon in my lifetime. But certainly in the future, all of those type of things will happen.
Just a point of curiosity here. If you could fly to the moon or go into outer space, would you do it?
Oh, definitely.
Oh,
So
now
I'm
see,
one of
when
the-
go ahead.
Yeah, I was just going to say I'm one of those ones that were interested in astronomy even before I went to kindergarten. I always laugh and tell people I was interested in space when I was knee-high to a grasshopper. And that really came because of the exposure to the space program. And so you wouldn't believe how many people became interested in space, interested in science in general, because of NASA itself and the establishment of NASA and the goal of putting human beings on the surface of the moon. And I'm hoping that in the future, when we're trying to redo this sort of process of going back to the moon and then on to Mars, that's going to get people excited, especially the young people, get them very excited in science in general. And that's what we need, today, is to have people pushing that sort of boundary into the next frontier.
And here you have, is this the, what is this? This is outside of UND, right?
Yeah, so this is about an hour from UND out in the dark site. This is near Inkster, North Dakota. So it's the Martins Observatory that's operated by our department. It's a 20-inch plane wave reflecting telescope, and the money was donated graciously by Erwin Martin and also money from the university itself to build the observatory. And so this is a good place where we bring students to train them on how to use a telescope and how to actually make observations of the sky. You can, for example, look at different stars to see if you can detect planets orbiting around those stars. You can look at galaxies like you see here. This is M51, the Whirlpool galaxy. So you can look for the appearance of a new star in these galaxies, which would signify a supernova that has gone off, an exploding massive star at the end of its life. And so there's a lot of interesting science that you can do with these type of telescopes. Now, this image itself is actually our first image that was taken just a couple years ago of a black hole itself. This is taken from the Event Horizon Telescope. And so this is the first time that we had conclusive evidence that black holes actually exist in nature. One way you can get around from explaining black holes, if you have trouble trying to understand what they are, is just say, well, somehow they don't form. But now we've taken a direct image of one. They are there, they do exist, and so we need to explain them.
Wow, that's really exciting to think that you could go to an observatory outside of Grand Forks and actually see this. Thank you so much for your time here, and UND has an excellent astrophysics program, I understand, and I hear you're a good professor out there, so that's something to look into if you have that interest. And we'll be right back.
Thank you very much.
Thank you.
We'll be right back to talk about motherhood when we come.